right, I have here the three rules in constructing a ray diagram in our convex lens. Remember, it's lens. The lens or the convex lens is characterized by a thicker center and then thinner edges. So if you will have to draw the convex lens, maybe you can have it this way. Here, it's thicker at the center, and then the edge is like thinner. Okay, and it's a popular lens used in magnifying glass, or even the lenses used in eyeglasses. What else? Like in microscope, the lens of a microscope, it's a convex lens, and camera as well. The lens in camera is a kind of convex lens. All right, so I will just erase first this thing, and we will apply the three rules in this case. So the first rule is a parallel ray rule. When we say parallel or parallel lines, these are lines that never meet. Okay, like for example, this is the first line and this is the second line. If you will continue it, they will never meet. That's a parallel lines. Or we can have it this way. This line will never meet. So that's a parallel lines. Parallel ray rule. A parallel ray, a ray parallel to the principal axis, will refract through a focal point or F on the other side of the lens. That's a pretty simple rule. We have this so-called the other side of the lens. Okay, and we have F here. F is our focal point. Remember that one? And this is also a focal point here. And we have the center of the curvature. Okay, center of curvature. Same here, center of curvature. And if you could still recall, this length here is equal to the length here. Like let's say 2 meters, this is also 2 meters. Same true on the other side of the lens, 2 meters, 2 meters. But my drawing isn't accurate. Okay, so right, let's continue. According to the rule, we have a parallel line or a ray that is parallel to the principal axis. It will refract. When we say refract, it will bend. Okay, it will bend. Like for example, the line is here, and then that's the ray or the light ray, and then it will gonna bend this way. Now let's do it. Let's say we have an object here. This is our object. Okay, and we will apply the first rule, the parallel ray rule. A parallel line or a ray parallel to the principal axis. Let's recall our principal axis is here. Principal axis or the optical axis, this line here. Okay, so we have a parallel ray here. So we can do it not this way because that's not parallel with the principal axis, but it must be this way. Just like that. And then what will happen next? It will refract or it will bend through the focal point on the other side of the lens. So in that case, here's our focal point on the other side of the lens. So we will have to continue our ray there, but this time it will be bending. It will bend or refract just like this. Okay, though my drawing is not perfectly at the focus or focal point, but yeah, if you will have your protractor and your ruler, you can perfectly put it there. Okay, or I will just change it. Okay, I guess this is better. All right, that's the first rule. A ray, this is a ray, and it's parallel with our principal axis. So this is going to be the ray, and it's parallel to our principal axis. Parallel means lines that never meet. Okay, please take note. So as easy as that. That's our first rule. Okay, now what about the second rule? Let's have the second rule now. Let's use another color. Let's have this like green or something, army green. Let's have the focal ray rule. Like focal ray rule, it has something to do with the focal point F. If you see this part here in our lens, it means the focal point. That's the distance from the lens. Okay. All right. So what are we going to do here? A ray passing the focal point before reaching the lens will emerge parallel to the principal axis after refraction. Remember, refraction is just the bending of the light ray. Okay, let's show it here. So a ray passing through the focal point, we have this focal point before reaching the lens will emerge parallel to the principal axis. Okay, let's do it. We have a ray here passing through the focal point. Let's continue it a little. It will emerge parallel. So a parallel, lines that never meet. So we can have it this way, parallel to our principal axis, just like that. Okay, that's our focal ray rule. Again, this is our ray, and it passed through the focus before refraction, before bending. Here's our bending refraction part here. Uh, it will emerge parallel to our principal axis. So our principal axis line and our refracted ray here, it's parallel to our principal axis. So that's the second rule, or the focal ray rule. Okay, we have now our last rule, which is about the center ray rule. Center here, it's not the center of curvature, but this time I will inform you that the center here means center of the lens. This one, that yellow dot there, that's the center part of the lens. Okay, a ray passing the center lens will continue straight without refracting. If we have a lens here and then we have a beam of light passing this way, it will gonna bend this way. So there's a bending point here, that's refraction. But this time in the center ray rule, there's no refraction happening. So let's try to draw it. A ray passing through the center of the lens will continue to the other side. So just like that. Okay. The ray passing through the center will continue straight without bending. So these are the three rules in doing ray diagram in convex lens.